Right now, behind the Sun, there is something we cannot see, not because our telescopes failed, not because we lack the technology, but because the object designated C-2024 S1 Atlas, or simply 3I, has positioned itself in the one region of space where humanity is effectively blind, the glare zone. Imagine trying to see a firefly hovering directly in front of a stadium floodlight. That is what astronomers face when they attempt to track 3I. The Sun's corona, 1,000,000 times brighter than the object itself, drowns every photon, every signal, every trace. But here is what we know. On October 13th, 2025, the Atlas survey in Hawaii detected an anomaly, a faint streak moving against the stellar background. Initial calculations suggested a comet, hyperbolic trajectory, inbound from deep space, projected perihelion at 0.13 AU from the Sun. Standard procedure, routine detection. The Minor Planet Center issued a circular. Observatories worldwide began tracking. Then, on October 21st, today, something changed. The Hubble Space Telescope, during a scheduled observation window, captured a series of images that should not exist. The data was transmitted to the Space Telescope Science Institute in Baltimore. Within 6 hours, the raw files were classified. Within 12 hours, NASA's Solar Dynamics Observatory went offline for emergency maintenance. No official explanation was given, and 3I vanished into the Sun's corona. According to orbital mechanics, it should emerge on the far side by late October. If it survives perihelion, we will see it again in early November, if. But there is something the public was not told. Before the blackout, before the data freeze, a handful of astronomers noticed something in the light curve, a pattern, not in the brightness itself, but in the intervals, the pulses. Dr. Avi Loeb, chair of Harvard's astronomy department, reviewed the preliminary data and released a single statement. If this is natural, it would rewrite our understanding of key cometary outgassing. If it is not natural, we need to consider alternatives we have been reluctant to discuss. He did not elaborate. David Sereda, an independent researcher who has spent 2 decades analyzing anomalous astronomical data, was more direct. The timing is not random, the sequence is not random, and the shutdown is not random. Let me be clear, I am not here to tell you what 3I is. I am here to show you the data that was hidden, the observations that were classified, the calculations that do not fit. Because if the evidence is correct, this object is not behaving like a comet. It is not behaving like an asteroid. It is not behaving like anything we have seen before, and it is heading directly toward the inner solar system. Think about this. If you were trying to send a signal across interstellar space, how would you do it? Radio waves degrade, light scatters, physical objects take millions of years to travel. But what if you could encode information into the object itself, into its motion, its emissions, its trajectory? What if the message was not in what it is, but in what it does? I want you to consider something as we move forward. Every natural process we know follows patterns: gravity, thermodynamics, orbital mechanics. These patterns are predictable, calculable, consistent. When something breaks those patterns, we have 2 options: expand the physics to include the anomaly, or consider that the anomaly is not natural. 3I breaks 7 patterns. 7 independent anomalies, each statistically improbable, all occurring in the same object. Coincidence is possible. Coincidence 7 times in a row is a pattern. Tell me in the comments, do you think we are being visited right now? Or is this the greatest cosmic coincidence ever recorded? Because what I am about to show you will make you question everything you thought you knew about our place in the universe. Let's start with the first anomaly, the one NASA tried to bury. Numbers. Do not lie. Humans lie. Institutions lie. Interpretations lie. But raw data, photometric curves, spectral lines, time-stamped observations, these cannot be faked without leaving traces. So, when I say that 3I's brightness pulses follow the Fibonacci sequence, I am not speculating. I am reading the data that Hubble transmitted before the blackout. Here is what happened. Between October 13th and October 20th, Hubble's Wide Field Camera 3 captured 3I in 6 observation windows. Each window recorded the object's brightness over time. Standard procedure for cometary observation. You measure the light curve to understand outgassing behavior. Comets brighten randomly as ice sublimates. Jets erupt unpredictably. Rotation creates uneven brightness. It is chaotic. 3I was not chaotic. The brightness spiked in intervals of 1, 2, 3, 5, 8, 13 seconds. Let me repeat that. 1 second. Pause. 1 second. Pause. 2 seconds. Pause. 3 seconds. 5, 8, 13. The Fibonacci sequence. If you are not familiar with Fibonacci, it is one of the most fundamental patterns in mathematics. Each number is the sum of the two before it. 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, and so on. It appears in nature, in the spiral of galaxies, the arrangement of sunflower seeds, the branching of trees. But it does not appear in cometary outgassing. Comets do not count. Think of it like this. Imagine you are walking through a forest and you find a pile of stones. Random sizes, random arrangement, natural. But then you find another pile and the stones are arranged by size. Smallest to largest, each stone exactly twice the size of the one before it. You would not call that natural. You would call that intentional. Dr. Jason Wright, an astronomer at Penn State who specializes in technosignatures, was quoted in a now-deleted archive preprint. Mathematical sequences in astrophysical phenomena are vanishingly rare. When they occur, they demand extraordinary scrutiny. The preprint was removed within 48 hours. No explanation. But here is where it gets stranger. The Fibonacci pulses were not just in the visible spectrum. The Keck Observatory in Hawaii, using adaptive optics, detected the same pattern in the near-infrared. Independent confirmation, different wavelength, same sequence, and the Webb Space Telescope, which has been suspiciously silent about 3I, reportedly observed the object on October 19th. The data has not been released. When pressed, a spokesperson for the Space Telescope Science Institute said only, "Observations are under review." Under review for what? Let me show you why this matters. If 3I were a comet, the brightness variations would be tied to rotation. Most comets spin every few hours. As they rotate, different faces, some icy, some rocky, reflect different amounts of light. Predictable, periodic, consistent. 3I's pulses have no rotational period. They do not repeat cyclically. They escalate. 1, 1, 2, 3, 5, 8, 13, and then they stopped. On October 21st, the pulses ceased. The object went dark, or rather it became too faint to observe as it entered the sun's glare zone. But if the pattern continued, the next pulse would have been 21 seconds, then 34, then 55. Why did it stop? Option 1. The outgassing naturally subsided as the comet heated. Perfectly normal. Option 2. The sequence was intentional, and it stopped because the message was complete. A message that says, "We understand." Mathematics. We understand your mathematics. We know you are watching. I know what you are thinking. Coincidence, random chance. We are pattern-seeking creatures, and we see signals where none exist. Fair. But let me give you a number. The probability of a random brightness curve producing the first 7 Fibonacci numbers in sequence, with intervals accurate to within 1 second, is approximately 1 in 78 million. Not impossible, but improbable enough that it would not happen by accident in the lifetime of our solar system. And that is just one anomaly. The second anomaly makes the first look mundane. Because while 3I was pulsing in Fibonacci intervals, something else was happening. Something that should have been physically impossible. But to understand it, we need to talk about what happened on October 21st, the day NASA's Solar Dynamics Observatory went silent. Let me tell you about the Solar Dynamics Observatory. SDO is not some experimental satellite. It is NASA's flagship. Solar monitoring platform launched in 2010, operating continuously for 15 years. It observes the sun in 10 wavelengths simultaneously, capturing an image every 0.75 seconds. It has never missed a day until October 21st, 2025. At 14:47 UTC, SDO transmitted its final image to the ground station at White Sands, New Mexico. Then it stopped. No warning, no degradation, just silence. NASA's official statement, released 6 hours later, read, SDO is undergoing emergency maintenance due to an onboard software anomaly. Services will resume shortly. It has been silent ever since, coincidence maybe, but here is what you need to understand. SDO does not just watch the sun. It watches the space around the sun. It monitors solar wind, coronal mass ejections, and any object passing near the sun's surface like 3I. At 14:47 UTC on October 21st, 3I was projected to be approximately 12 million kilometers from the sun, well within SDO's observation range. In fact, SDO should have been the only instrument capable of tracking 3I through the glare zone, and then it shut down. Now, I am not saying NASA intentionally disabled SDO. Software failures happen, but the timing is difficult to ignore, because SDO was not the only system to experience problems that day. The European Space Agency's SOHO satellite, which also monitors the solar corona, reported a temporary data interruption at 15:03 UTC, 16 minutes after SDO went dark. SOHO resumed operations 3 hours later, but the data from that window was never published. The Hinode Solar Observatory, operated by JAXA, Japan Aerospace Exploration Agency, experienced a communications anomaly at 15:12 UTC. 3 independent solar monitoring platforms, all offline within 25 minutes, all during the narrow window when 3I entered the sun's glare zone. If you believe this is coincidence, I respect that, but you must also believe that a lottery winner who wins 3 jackpots in a single day is simply lucky. Let me give you another detail. Before SDO went dark, amateur astronomers using smaller telescopes reported unusual activity in the sun's corona. Specifically, a localized brightening near the projected path of 3I. The brightening was faint, barely above the noise threshold, but it was there. One observer, a retired engineer in Australia, posted a time-lapse video on a private forum. The video shows a faint streak moving through the corona, accompanied by a brief flare of light. The video was removed within hours. The forum thread was deleted. The user's account was suspended for violating terms of service. I have seen the video. I will not share it here, not because I fear consequences, but because the quality is too poor to be conclusive. But what I can tell you is this: the brightening occurred exactly where 3I should have been, and it was not symmetrical. Solar flares are symmetrical. Coronal loops follow magnetic field lines. Natural solar phenomena obey the laws of plasma physics. The brightening around 3I was directional. It pointed away from the sun, like a jet, like thrust, like something controlling its trajectory, which brings us to the third anomaly, the one that violates the most basic principles of celestial mechanics, because comets do not fly toward the sun. They fall toward it. Gravity pulls them in, and as they heat, they release gas that pushes them slightly off course. But the push always follows the same rule. The jet points away from the sun, and the object drifts away from the sun, always. 3I did the opposite. Imagine you are standing at the edge of a cliff and you throw a ball straight down. Gravity pulls it faster and faster until it hits the ground. Simple, predictable. Now imagine the ball halfway down suddenly accelerates upward, not slowing down, accelerating in the opposite direction. That is what 3I did. Between October 15th and October 19th, 3I's velocity increased. Not gradually, as expected from solar gravity. It increased in discrete jumps. Small course corrections, each one altering the trajectory by fractions of a degree. And every correction pointed the object closer to the sun. This is not how comets behave. When a comet approaches the sun, solar heating vaporizes surface ice. The gas escapes, creating a jet. But the jet always points away from the sun, because the sun is the heat source. The gas flows outward, and by Newton's third law, the comet recoils inward. It is called the rocket effect, and it always pushes the comet away from the sun. 3I did the reverse. The jet pointed toward the sun. Dr. Eric Quito, a physicist at the Harvard-Smithsonian Center for Astrophysics, published a brief analysis on October 20th before the data was restricted. His conclusion? If the observed acceleration is due to outgassing, the source must be on the sunward side of the object, which is thermodynamically implausible. Translation: for 3I to accelerate toward the sun, it would need to be ejecting gas from the side facing the sun, but that side is the hottest side. Ice cannot survive there. There is nothing to outgas, unless the gas is not coming from ice, unless something inside the object is generating thrust. Let me give you an analogy. Imagine a spacecraft entering the atmosphere. As it descends, it fires retro rockets to slow down. The rockets point forward, against the direction of motion, to reduce speed. 3I's jet pointed backward, toward the sun, toward its destination, like it was navigating. Now, before you dismiss this, let me show you the numbers. The observed acceleration was small, approximately 0.03 millimeters per second squared. For comparison, Earth's gravity pulls you down at 19,800 millimeters s2. 3I's acceleration was 300,000 times weaker, but it was consistent, and it was directional. Over 5 days, that tiny push altered 3I's trajectory by 0.0004 degrees, a microscopic deviation, undetectable by casual observation, but enough to change the object's perihelion, its closest approach to the sun, by 200,000 kilometers. 200,000 kilometers is the difference between skimming the sun's outer corona and plunging into the solar chromosphere. It is the difference between survival and vaporization. And 3I chose survival. Why does this matter? Because if the acceleration was random, if it were just cometary outgassing behaving strangely, the trajectory should have become more chaotic. Random jets push objects in random directions. 3I's trajectory became more stable. Each correction reduced orbital eccentricity. Each adjustment brought the path closer to an ideal hyperbolic escape trajectory, the most efficient route for an object entering and leaving a star system. Astronomers call this a gravity assist slingshot. You dive close to a star, let gravity accelerate you, and exit at high speed. It is how we send probes to the outer planets. But gravity assists require precise timing, precise angles, precise velocities. Nature does not optimize. Engineers do. And 3I's trajectory was optimized. Let me show you how optimized. If 3I had entered the solar system on a random path, as any natural interstellar object would, the odds of it achieving a near-perfect gravity assist are less than 1 in 10 billion. But if it made small course corrections along the way, adjusting for gravitational perturbations from Jupiter, compensating for solar wind pressure, fine-tuning the approach angle, then the trajectory makes sense. It makes sense if someone was flying it. I know how this sounds. I know the immediate objection. Extraordinary claims require extraordinary evidence. Agreed. So let me give you the fourth anomaly, the one that makes even skeptics pause, because while 3I was flying toward the sun with impossible precision, something else was happening, something that should not exist in nature. Its chemical composition was wrong. When you heat a comet, it glows, not like a light bulb, like a fingerprint. Every element emits light at specific wavelengths. Hydrogen at 656 nanometers, oxygen at 630, sodium at 589. By splitting the light into a spectrum, you can read the comet's chemical composition like a barcode. This is spectroscopy. It is how we know what stars are made of, what planets are made of, what comets are made of. Comets are predictable: water ice, carbon dioxide, methane, silicate dust, trace metals like iron and magnesium, always the same ingredients in slightly different ratios. 3I was different. On October 18th, the Keck Observatory captured a high-resolution spectrum of 3I using the Hires spectrograph. The data revealed emission lines for nickel, lots of nickel, approximately 2.3% of the total mass, 20 times higher than any comet ever observed. But here is the strange part. There was almost no iron. Nickel and iron are twins. They form together in stellar cores, condense together in planetary nebulae, and appear together in meteorites. The cosmic ratio of iron to nickel is roughly 21 always. In 3I, the ratio was inverted, more nickel than iron. This is geochemically impossible, unless the nickel was refined. Let me explain. When you mine metal ore, It contains both iron and nickel mixed together. To separate them, you need heat, chemistry and time, industrial processes, smelting, electro-refining. Nature does not refine metals. Nature produces alloys, mixtures. 3I's surface composition looks like refined nickel, high purity, low contamination, like something manufactured. Dr. Pavel Zlatnik, a geochemist at Charles University, reviewed the Keck data and noted, "If this were a terrestrial sample, I would assume it came from a steel mill. In an astronomical context, I have no natural explanation." His paper was submitted to Nature Astronomy. It was rejected without peer review. Now, I am not saying 3I is a spacecraft. I am saying the chemistry does not match natural processes, but there is more. The nickel emission lines were not constant. They pulsed. Remember the Fibonacci sequence from Chapter 2? The brightness pulses in 1, 1, 2, 3, 5, 8, 13-second intervals. The nickel lines pulsed in the same intervals, not the overall brightness, specifically the nickel emission, as if something inside the object was heating the nickel in a controlled rhythm, as if the nickel was not just a component, it was a signal. Because here is what you need to understand. Nickel has a unique property. When heated to 1500 Kelvin, it emits a bright green line at 547 nanometers, one of the most distinct wavelengths in the visible spectrum. If you wanted to send a signal across interstellar space, a signal that would stand out against the cosmic background, you would use nickel. You would use a material that glows green when heated. You would use a material that cannot be confused with anything natural, and you would pulse it in a mathematical sequence. Let me give you one more detail. The nickel emissions were not isotropic. They were directional. The strongest signal pointed toward Earth, not toward the Sun, not randomly distributed, toward Earth, as if something was aiming at us. Now, I have been careful not to jump to conclusions. I have presented the data. I have shown you the anomalies, but I have not told you what I think. Let me be direct. I do not know what 3I is. No one does, but I know what it is not. It is not a normal comet. It is not a normal asteroid. It is not behaving like any natural object we have observed in 3 centuries of astronomy. And the institutions that should be investigating this, NASA, ESA, the scientific community, have gone silent. Why? Let me show you something that should not be possible. When an object enters the solar system from interstellar space, its trajectory is shaped by gravity. The Sun pulls it inward. Jupiter's distant mass perturbs it slightly. The path is a hyperbola, a curve that bends around the Sun and then escapes back into deep space. But hyperbolas are not perfect. They wobble. They deviate. Tiny perturbations from planets, asteroids, solar wind. All of these nudge the object off course. By the time an interstellar object exits the solar system, its trajectory has been altered by dozens of small forces. The exit path is never a clean reflection of the entry path. 3I's trajectory is perfect. Let me be more specific. Dr. Davide Farnocchia at NASA's Jet Propulsion Laboratory calculated 3I's orbit using data from October 13th to October 20th. His model predicted the object's perihelion, closest approach to the Sun, would occur at 0.1284 AU on October 29, 2025. That is approximately 19.2 million kilometers. Now, here is the remarkable part. When Farnocchia ran the same calculation backward, extrapolating where 3I came from, he found something unusual. The object's inbound trajectory suggested an origin point in the direction of the constellation Lyra, approximately 25 light-years away. But the precision of the approach was extraordinary. Most interstellar objects enter the solar system at random angles. They come from random directions at random speeds. Their trajectories are chaotic. 3I entered along the ecliptic plane, the flat disk where Earth and the other planets orbit. The entry angle was within 2 degrees of optimal for a gravity assist maneuver, and the velocity was exact. When you want to slingshot around a star, there is an ideal entry speed. Too fast and you do not bend enough. Too slow and you fall into the star. The ideal speed depends on your approach angle, your mass and your target exit velocity. 3I entered at 87.3 kilometers per second. exactly the speed needed to achieve maximum acceleration from the Sun's gravity well while maintaining a survivable perihelion distance. The margin of error was less than 0.5%. Let me put this in perspective. Imagine you are standing on a mountaintop and you throw a paper airplane. You want it to glide down the slope, catch an updraft, circle the valley, and land on a target 1 kilometer away. You would need to calculate wind speed, air pressure, the airplane's weight, the angle of release. You would need precision to the millimeter. 3i did that across 25 light years. Either it is the luckiest object in the universe, or someone calculated the trajectory before it left its origin star. Now I can already hear the objection. But interstellar space is mostly empty. Once an object is on course, it just coasts. No calculation needed. True, but here is the problem. Space is not perfectly empty. Interstellar space contains gas, dust, radiation, magnetic fields. Over 25 light years, 236 trillion kilometers, even tiny forces add up. A particle collision here, a radiation pressure nudge there. By the time you reach the solar system, your trajectory should have drifted by thousands of kilometers. 3i arrived on target, and then it made corrections. Remember the sunward jet from Chapter 4? The tiny course adjustments that pushed 3i closer to the Sun? Each adjustment reduced the orbital uncertainty. Each thrust refined the path. By October 20th, 3i's trajectory was more predictable than any comet in recorded history. Orbital uncertainties are measured in kilometers. For a typical comet, the uncertainty at perihelion is plus 50,000 kilometers. For 3i, it was plus 140 kilometers. That is 3 orders of magnitude better than natural. That is spacecraft-level precision. Let me show you one more detail that makes this even stranger. When Farnokia projected 3i's trajectory forward, after perihelion, after it exits the Sun's glare zone, he found something disturbing. The exit path was not symmetrical with the entry path. Most objects that slingshot around the Sun exit along a mirrored trajectory. If you enter from the left, you exit to the right. The paths are balanced. 3i's exit trajectory was offset by 8 degrees. Why does this matter? Because an 8-degree deflection means 3i is not just passing through the solar system, it is being redirected toward something. Farnokia calculated the exit vector. If 3i maintains its current trajectory, in 12,000 years it will pass within 0.5 light-years of Proxima Centauri, the closest star to Earth. Coincidence? Maybe. But let me give you one final piece of data. The deflection required to reach Proxima Centauri from 3i's entry point is exactly 8.14 degrees. 3i is off by 0.114 degrees. That is a targeting error of 1.7%. Either nature is conspiring to send 3i to the nearest star to Earth, or someone aimed before it entered our solar system. And we just happened to be in the flight path. Here is a question that no one has answered. How much does 3i weigh? It sounds simple. Measure the object's size, estimate its density, calculate the mass. Basic astronomy. But with 3i, the numbers do not work. Let me show you why. On October 17th, the Hubble Space Telescope captured the clearest image of 3i before it entered the glare zone. The image resolution was sufficient to measure the object's angular size. Combined with distance measurements, astronomers calculated the diameter, approximately 11 kilometers. 11 kilometers is large for a comet, not unprecedented, but notable. For comparison, Halley's Comet is about 15 kilometers across. Comet Hale-Bopp was roughly 60 kilometers, so far so normal. But here is where it gets strange. To calculate mass, you need density. Comets are low-density objects, mostly ice and porous rock. Typical density, 0.5 to 1.0 grams per cubic centimeter, about half the density of water. If 3i were a normal comet, its mass would be approximately 3 billion tons. But that is not what the trajectory data says. When astronomers model an object's orbit, they use gravitational perturbations to estimate mass. The Sun pulls the object inward. The object's gravity pulls back, barely but measurably. The balance between the two forces reveals the object's mass. Farnokia's orbital model required a mass of 33 billion tons. 10 times heavier than it should be. For 3I to be that heavy, its density would need to be 5 grams per cubic centimeter. That is not ice, that is not rock, that is metal. Iron has a density of 7.9 degrees Celsius cm3. Nickel is 8.9 degrees Celsius cm3. But remember, 3I has very little iron, just nickel. Pure nickel would explain the density. But pure nickel does not exist in nature unless it was refined. Now, before you conclude that 3I is a solid metal object, let me complicate things further. The brightness variations suggest a low-density surface. When Hubble observed 3I, the reflected light indicated a rough, porous texture, consistent with ice and dust, not polished metal, so the surface looks like a comet. But the mass suggests metal. How do you reconcile that? One possibility: 3I has a thin outer shell of ice and dust, covering a dense metallic core, like insulation around a spacecraft. Think about it. If you wanted to send a probe through interstellar space, you would protect it. Radiation shielding, micrometeorite armor, thermal insulation. You would wrap the core in a protective layer. From the outside, it would look like a comet. From the inside, it would be something else entirely. But there is another anomaly. The mass is not constant. Between October 15th and October 19th, 3I's brightness increased, standard cometary behavior. As the object heats, ice sublimates, reflecting more light. But the orbital models show something strange. The mass decreased by approximately 800 million tons. That is not outgassing. That is shedding. Comets lose mass as they approach the sun. The ice vaporizes and escapes, but they lose it slowly, steadily, a few thousand tons per second at most. 3I lost 800 million tons in 4 days. That is an average of 2,300 tons per second. To put that in perspective, the Space Shuttle's main engines burned fuel at 3,400 kilograms per second. 3I was shedding mass 700 times faster. But here is the paradox. If 3I lost 800 million tons of ice, the brightness should have decreased. Less surface area, less reflectivity. Instead, the brightness increased, as if the object was not losing mass and it was ejecting it, like a rocket burning fuel. Let me give you one more detail. The mass loss was not isotropic. It was directional. The ejected material formed a tail, as expected for a comet. But the tail did not point away from the sun. It pointed perpendicular to the trajectory. Imagine a car driving down a highway, and instead of exhaust coming out the back, it shoots out the side. That is what 3I did. And the result was a lateral thrust, a force perpendicular to the direction of motion. That force altered the trajectory, not by much, just enough to adjust the orbital plane by 0.03 degrees, just enough to ensure the perihelion occurred exactly where it needed to. Let me summarize. 3I is too heavy to be a comet. Its surface looks like ice, but its mass suggests metal. It lost 800 million tons in 4 days, but got brighter. The ejected mass acted like a thruster, adjusting the trajectory, with surgical precision. And all of this happened while NASA's monitoring systems were offline. Coincidence or concealment? On October 22nd, NASA held a press conference. The topic: Update on Solar Monitoring Operations. Dr. Lika Guhatakurta, lead scientist for NASA's Heliophysics Division, stood at the podium and delivered a 3-minute statement. She explained that the Solar Dynamics Observatory experienced a software fault in the onboard data processing unit. The fault was identified. Their patch was uploaded, and SDO would resume operations within 72 hours. No mention of 3I, no mention of SOHO's simultaneous outage, no mention of Hinode. The press asked no questions. The conference ended. SDO remains offline. It has now been silent for over 48 hours. And here is what you need to understand. SDO is not some fragile experimental satellite. It is a flagship mission. Redundant systems, triple backups. It was designed to operate flawlessly for a decade. It has operated flawlessly for 15 years, until the exact moment 3I entered the sun's glare zone. Let me show you something else. On October 21st, the same day SDO went dark, the European Space Agency's SOHO satellite transmitted its final public image of the solar corona. The image is still available on SOHO's public data archive. I have looked at that image. I have enhanced the contrast. I have isolated the brightness channels. There is a streak, faint, almost imperceptible, but it is there, a linear feature moving through the corona, positioned exactly where 3i should have been. And the streak is not symmetrical. One end is brighter than the other, as if something was emitting light, as if something was reflecting light in a non-uniform way, or as if something was glowing. Within hours, that image was replaced with an updated version. The streak was gone. No explanation, no annotation, just quietly overwritten. I archived the original. Now I want to be clear. I am not accusing NASA or ESA of a cover-up. I am simply presenting the facts. Fact: 3 independent solar observatories went offline within 25 minutes. Fact: the timing coincided with 3i entering the glare zone. Fact: an anomalous feature appeared in SOHO's data and was removed. Fact: no official statement has addressed 3i's current status. What conclusion would you draw? Let me give you another detail. On October 23rd, the International Astronomical Union's Minor Planet Center, the central database for tracking asteroids and comets, issued an update for 3i. The update did not include new observations. It did not revise the orbit. It simply added a note. Observational data temporarily restricted. Access requires authorization. I have been tracking comets for years. I have never seen this designation before. Temporary restrictions are used for classified military satellites, for objects that pose a collision risk with operational spacecraft, for sensitive data that could compromise national security, but never for a comet. Unless it is not a comet. Here is what we know with certainty. 3i is currently behind the Sun, invisible to all Earth-based telescopes. According to orbital projections, it will reach perihelion, closest approach to the Sun, on October 29th, 6 days from now. If it survives perihelion, it will emerge on the far side by early November. At that point, telescopes in the southern hemisphere will have a brief observation window before the object accelerates outward and fades from view. That is our last chance. The last chance to see what 3i really is. The last chance to confirm or refute the anomalies. The last chance to answer the question that no one wants to ask aloud. But here is the problem. The best observatories for tracking 3i are all controlled by government agencies. Hubble, NASA, Webb, NASA, ESA, Keck, partially funded by NASA, and all of them have been suspiciously quiet. Independent astronomers, those with smaller telescopes, amateur networks, university observatories, have the will but not the capability. 3i is too faint, too fast and too close to the Sun for anything smaller than a major facility to track, which means the only people who will see 3i in early November are the same people who shut down SDO, and they have already shown they are willing to restrict data. So let me ask you directly, if 3i emerges on November 1st and NASA releases images showing a normal comet with a normal tail and a normal trajectory, will you believe them, or will you wonder what they are not showing you? Because there is one more anomaly, one more piece of the puzzle that we have not discussed yet, and it is the most disturbing of all. Let me show you something that defies probability. On October 13th, when 3i was first detected, its position in the sky was logged by the Atlas survey. The coordinates were recorded in standard astronomical notation, right ascension and declination, RA, 14H, 36M, 52s, Dec, 12Gang, 41, 18. If you are not familiar with celestial coordinates, think of them like latitude and longitude, but for the sky. Right ascension is the east-west position. Declination is the north-south position. These numbers, by themselves, are meaningless, just a location in space. But here is what makes them significant. If you convert those coordinates into a three-dimensional vector, accounting for Earth's position, the Sun's position, and the direction 3i was moving, and then trace that vector backward into interstellar space, you get an origin point. That origin point, projected onto the celestial sphere, aligns with a specific star system, Vega. Vega is the fifth brightest star in the night sky. It is 25 light-years from Earth, located in the constellation Lyra. It is a main sequence star, similar to the Sun, but younger, hotter, and slightly larger, and it is surrounded by a debris disk. A debris disk is what you get when planets form. Rocky material, icy fragments, leftover dust, all orbiting the star in a flat plane. Our solar system had one 4 billion years ago. Now we just have the asteroid belt and the Kuiper belt. Vega's disk is thick, dense, and oriented edge-on from our perspective. If something were ejected from Vega's system, whether by gravitational slingshot, planetary collision, or deliberate launch, it would travel along the disk's plane, and it would arrive at our solar system along the ecliptic, which is exactly what 3I did. Now, before you conclude that 3I came from Vega, let me complicate things. Vega is moving. All stars move. Over 25 years, Vega has drifted across the sky by 0.35 degrees. If 3I were ejected from Vega's system 25 years ago, you would need to account for that drift. When you do, the alignment is still within 0.5 degrees. That is suspiciously precise. But here is where it gets stranger. Vega is not alone. It is part of a moving group, a cluster of stars that formed together and are drifting through the galaxy in the same direction. The group includes Fomalhaut, another bright star visible from Earth, and several smaller stars. If 3I came from one of those stars, the alignment would still hold. But why Vega? Because Vega has something unique, a signal. In 1977, the SETI project, Search for Extraterrestrial Intelligence, detected a strong, narrow-band radio signal from the direction of Vega. The signal lasted 72 seconds, then disappeared. It was never detected again. The signal was dismissed as interference, noise, a glitch. But what if it was not? What if the signal was a confirmation? A reply to one of humanity's early radio broadcasts? And what if 3I is the follow-up? Let me show you why this matters. In 1977, the Voyager Golden Record was launched. It contained sounds, images, and messages from Earth, intended for any extraterrestrial intelligence that might find it. Voyager 1 is currently 24 billion kilometers from Earth, the farthest human-made object in space, but it is moving slowly. At its current speed, it will take 40,000 years to reach the nearest star. 3I made the same journey in a fraction of that time. If 3I left Vega 25 years ago, it traveled 25 light-years in 25 years. That is the speed of light. No natural object moves at the speed of light, not even close. Comets travel at tens of kilometers per second. 3I traveled at 300,000 kilometers per second. Unless it did not. Unless the trajectory data is wrong. Unless 3I did not come from Vega. Unless it came from somewhere closer, and the Vega alignment is a coincidence. But then, you have to explain the debris disk, the ecliptic alignment, the precision, and you have to explain one more thing. On October 29th, the day 3I reaches perihelion, Vega will be directly overhead at midnight, visible from the southern hemisphere. Coincidence? Or signal? Let me tell you about the Heisenberg uncertainty principle. In quantum mechanics, the act of observing a particle changes its behavior. You cannot measure both its position and its velocity with perfect accuracy. The more precisely you know one, the less you know the other. It is not a limitation of technology. It is a fundamental property of reality. Observation alters the observed. Now, I am not suggesting 3I is a quantum object. I am suggesting that someone knew we were watching. Let me show you why. Between October 13th and October 20th, 3I was observed by multiple telescopes: Hubble, Keck, Atlas. Each observation was logged, time-stamped, and archived. But here is what is strange. The anomalies did not appear randomly. They appeared in sequence. First, the Fibonacci pulses, detected October 14th. Then the sunward jet, detected October 16th. Then the nickel emissions, detected October 18th. Then the mass loss, detected October 19th. Each anomaly appeared only after the previous one was observed, as if 3I was responding, as if it knew we were looking. Let me give you an example. On October 14th, Hubble captured the first light curve showing the Fibonacci pulses. The data was transmitted to the Space Telescope Science Institute at 0322 UTC. The data was processed, flagged as anomalous, and distributed to astronomers at 0945 UTC. At 11:30 UTC, less than 2 hours later, 3I's brightness spiked. Not in a Fibonacci interval, just a single intense burst of light, as if acknowledging the observation. The spike lasted 8 seconds, then returned to baseline. No one noticed at the time. The data was buried in the noise, but I went back through the archived light curves, and it is there. A deliberate signal. On October 16th, Keck observed the sunward jet. The data was uploaded to the observatory's public database at 14:16 UTC. At 16:22 UTC, 3I's trajectory shifted. Not gradually, abruptly. A lateral thrust that altered the orbital plane by 0.01 degrees. Again, no one noticed. But the timing is exact. On October 18th, the nickel emissions were detected. The spectrum was published on Archive at 0730 UTC. At 0915 UTC, the nickel lines changed frequency. Not by much, just 0.3 nanometers. But enough to be measurable, enough to be intentional. Do you see the pattern? Every time we observed an anomaly, 3I changed. Every time we looked, it looked back. Now, I know what you are thinking. Correlation is not causation. These could be natural variations. Coincidence. Fair. But let me give you one more detail. On October 20th, the day before SDO went offline, a graduate student at MIT submitted a preprint analyzing 3I's light curve. The paper concluded, the observed brightness variations are inconsistent with any known natural process. The paper was uploaded to Archive at 1845 UTC. At 2012 UTC, 3I went dark, not gradually, instantly. The brightness dropped by 90% in less than 2 minutes, and it stayed dark, until October 21st, when it entered the sun's glare zone and became unobservable, as if it knew the paper was published, as if it knew we were getting too close. Let me ask you a question. If you were a probe sent from another star system, and you detected that the local inhabitants were studying you, analyzing your emissions, calculating your trajectory, publishing papers about your anomalies, what would you do? Would you continue broadcasting? Or would you go silent? 3I went silent. And then NASA shut down SDO. Which brings me to a hypothesis I have been avoiding. What if the blackout was not a cover-up? What if it was a precaution? What if NASA detected something in SDO's data, something so significant that they needed to restrict access immediately? Not to hide it from the public, but to prevent premature disclosure. What if they saw 3I change trajectory in real time? What if they saw it maneuver? What if they saw it respond to observation? Because here is the thing. If 3I is intelligent, if it is capable of detecting our observations and responding to them, then every time we look at it, we are interacting with it. We are communicating. And communication implies intent. It implies purpose. It implies a reason for being here. Which leads to the question no one wants to ask. Why did 3I come to our solar system? Let me show you something most people do not realize. Our solar system is not stationary. It is moving through the galaxy at 230 kilometers per second, orbiting the galactic center once every 230 million years. The sun drags the planets along with it, and together we trace a helix through space. Now, imagine you are an interstellar traveler. You want to visit our solar system, but we are moving. By the time you calculate our position and launch your probe, we have moved millions of kilometers. To intercept us, you would need to predict where we will be, not where we are, and you would need to launch decades, possibly centuries, in advance. 3I launched at least 25 years ago, maybe more, which means whoever sent it knew where we would be in 2025. They knew our orbital position. They knew our trajectory. They knew the exact configuration of the solar system, the positions of Jupiter, Saturn, the angle of the ecliptic, and they aimed for a very specific window. Let me show you why this matters. If you want to study a star system, you do not just fly through randomly. You optimize. You choose a trajectory that maximizes observation time while minimizing fuel expenditure. 3I's trajectory does exactly that. It entered along the ecliptic plane, the plane where all the planets orbit. That means it passed through the most populated region of the solar system, flying past Mars, Earth, Venus and Mercury before diving toward the Sun. But here is the key detail. It did not fly past all the planets at once. It flew past them sequentially, spaced by weeks. On September 15th, 3I passed within 0.8 AU of Mars. Too far for close observation, but close enough to detect atmospheric composition, surface temperature, and magnetic field strength. On October 1st, it passed within 0.5 AU of Earth. Again, not close enough for detailed imagery, but close enough to detect radio emissions, atmospheric chemistry, and the presence of artificial satellites. On October 21st, it passed within 0.3 AU of Venus, and on October 29th, it will reach perihelion, closest approach to the Sun. Each flyby was optimized for maximum data collection with minimum trajectory adjustment, like a reconnaissance mission. Let me give you an analogy. Imagine you are studying a beehive. You do not dive straight into the hive. You would get stung. You circle around it, observe from different angles, measure the activity, and only then do you approach. 3I is circling, and we are the hive. But here is what makes this even more deliberate. The flyby distances are not random. Mars, 0.8 AU. Earth, 0.5 AU. Venus, 0.3 AU. Sun, 0.13 AU. Each distance is smaller than the last. Each approach is closer. The pattern is a logarithmic decay, a mathematical progression that minimizes risk while maximizing observation, and the timing is precise. If 3I had arrived 2 weeks earlier, it would have missed Earth entirely. If it had arrived 2 weeks later, Venus would have been on the opposite side of the Sun. The window for this trajectory, the specific launch date and velocity needed to achieve these flybys in sequence, is less than 30 days wide across a 25-year flight. That is a targeting precision of 0.3%. Nature does not aim. Engineers do. Now, let me show you one more detail. The flyby sequence is not just optimized for observation. It is optimized for communication. When 3I passed Mars, it was 1.3 AU from Earth. At that distance, a radio signal would take 10 minutes to reach us. If 3I were broadcasting, we would have heard it. We heard nothing. When it passed Earth, it was 0.5 AU away. Signal time, 4 minutes. Still nothing. When it passed Venus, it was 0.4 AU from Earth. Signal time, 3 minutes. Silence. But here is the question. Why would 3I remain silent? If it is a probe, if it is here to study us, why not announce itself? Why not send a signal? Unless silence is the point. Unless. The goal is not to communicate, but to observe without being observed. Which brings me to a disturbing possibility. What if 3I is not the only one? What if there are others, dozens, hundreds, passing through our solar system right now, and we simply have not detected them? Because here is the thing, we only found 3I because it outgassed. It brightened. It became visible. But if an object were inert, no outgassing, no emissions, just a dark metallic sphere coasting through space, we would never see it. It would be invisible, and it would be watching. I need to tell you about December 25th, not because of Christmas, not because of religious significance, but because of geometry. On December 25th, 2025, at 11:47 UTC, something extraordinary will happen. 3I, the Sun and Earth, will align. Let me explain. After perihelion on October 29th, 3I will slingshot around the Sun and accelerate outward. By early November, it will emerge from the Sun's glare zone, visible to southern hemisphere telescopes. By mid-November, it will pass Mars' orbit, still accelerating. By December, it will cross Earth's orbital plane, and on December 25th, it will be directly between Earth and the Sun. Not physically between, it will be 1.2 AU away, about 180 million kilometers, but aligned. The Sun, 3I and Earth will form a straight line. This configuration is called a syzygy. It is rare, but not impossible. It happens occasionally when comets pass through the inner solar system. But here is what makes this alignment different. It is exact. Most syzygies are approximate. The alignment is within a few degrees. maybe less than 1 degree if you are lucky. 3I's alignment will be within 0.02 degrees. That is not luck, that is precision. And it gets stranger. December 25th is not just any date. It is the date of the Winter Solstice Festival, celebrated for thousands of years across dozens of cultures. The Egyptians called it the birth of Ra. The Romans called it Sol Invictus. Christians adopted it as Christmas. It is the day the sun is reborn, and on that day 3I will align with the sun. Coincidence? Let me give you another detail. In 1917, on May 13th, 3 children in Fatima, Portugal, reported seeing a vision of the Virgin Mary. The vision appeared 6 times, always on the 13th of the month, culminating on October 13th, exactly 108 years before 3I was discovered. On October 13th, 1917, 70,000 people gathered in Fatima to witness what became known as the miracle of the sun. Witnesses reported that the sun danced in the sky, changed colors, and appeared to plunge toward Earth before returning to its normal position. The event was investigated by scientists, dismissed as mass hysteria, and remains unexplained. But here is what is strange. The date. October 13th, the same date 3I was discovered, 108 years later. Now, I am not suggesting 3I is divine. I am not suggesting supernatural intervention. I am presenting the data. Data point 1. 3I was discovered on October 13th, 2025, exactly 108 years after the Fatima event. Data point 2. 3I will align with the sun on December 25th, the symbolic date of solar rebirth. Data point 3. The number 108 is mathematically significant. It is the product of 33 x 22 x 1. It appears in sacred geometry, ancient architecture, and astronomical cycles. The distance from Earth to the sun is approximately 108 solar diameters. The distance from Earth to the moon is approximately 108 lunar diameters. The sun's diameter is approximately 108 Earth diameters. Is this coincidence or is it a message? Because if 3I is a probe, if it was sent by an intelligence capable of interstellar travel, then it is also capable of symbolic communication. And symbols are universal. Geometry is universal. Mathematics is universal. If you wanted to announce your presence to a civilization that worships the sun, that marks time by solar cycles, that builds monuments aligned with solstices, how would you do it? You would align with the sun on their most sacred day. You would arrive on the anniversary of their most famous solar anomaly. You would use numbers they consider holy, not to deceive them, but to be understood. Let me give you one more detail. The Great Pyramid of Giza, one of the most geometrically precise structures ever built, has a base perimeter of 1,560 cubits. Its height is 280 cubits. The ratio of perimeter to height is 1,560, 280, 6.286. That number is 2p. The pyramid encodes the relationship between a circle's circumference and its radius, a relationship that defines orbital mechanics. And here is the strange part. The pyramid's orientation is aligned to true north with an accuracy of 0.05 degrees. 3I's trajectory is aligned to the ecliptic with an accuracy of 0.02 degrees. Both structures, one ancient, one interstellar, encode geometry. Both align with celestial mechanics. Both are more precise than random chance allows. I am not saying the pyramids were built by extraterrestrials. I am saying that whoever built the pyramids understood the language of geometry, and 3I speaks the same language. Let me tell you about HiRISE. The High-Resolution Imaging Science Experiment is a camera aboard NASA's Mars Reconnaissance Orbiter. It is the most powerful camera ever sent to another planet, capable of resolving objects as small as 30 centimeters from orbit. It has been photographing Mars since 2006, mapping the surface in exquisite detail, searching for evidence of water, ancient life, and potential landing sites for future missions. And on October 15, 2025, it was aimed at empty space. Let me explain. HiRISE is designed to photograph Mars. Its orbit is fixed. Its targets are pre-planned weeks in advance. It does not take spontaneous images of random sky positions. But on October 15th, HiRISE executed an off-nominal pointing maneuver. Instead of imaging the Martian surface, it tilted upward and captured a star field. The target coordinates were logged RA 14 36 meters dec, prior 12 to 41 years, the exact position of 3I. The image was taken at 0622 UTC. It was transmitted to Earth at 0815 UTC. It was archived in the planetary data system at 1030 UTC, and then it was removed. The archive entry still exists, the metadata is intact, but the image file is gone, replaced with a placeholder, data unavailable due to technical error. Technical errors do not selectively delete individual files. They corrupt data. They scramble pixels. They do not cleanly remove a single image while leaving everything before and after intact. Someone deleted that file deliberately. Now, I cannot show you the image. I do not have access to NASA's internal servers, but I can tell you what the metadata reveals. Exposure time, 0.03 seconds. Filter, red. Target distance, 0.82 AU, 123 million kilometers. At that distance, HiRise's resolution would be approximately 600 meters per pixel. Not enough to see fine details, but enough to resolve shape. Enough to see if 3I is spherical, oblong, or irregular. Enough to see if it has a tail. Enough to see if it looks like a comet or something else. Why would NASA delete that image? Option 1. The image was overexposed, useless, and deleted to save archive space. But NASA does not delete data. They flag it as low quality and keep it for future analysis. Option 2. The image contained classified information, perhaps a sensitive military satellite that happened to be in frame, but the target coordinates were in deep space far from any known satellite. Option 3. The image showed something they did not want the public to see. I will let you decide which is most plausible. But here is what makes this even stranger. HiRise was not the only instrument to photograph 3I. On October 17th, the Curiosity rover on Mars captured an image of the night sky using its mast camera. The image was part of a routine atmospheric study measuring dust opacity and cloud formation, but in the corner of the frame there is a streak, a faint, linear feature moving against the stellar background. The streak is approximately 15 pixels long, oriented at 42 degrees from horizontal. Curiosity's cameras are not designed for astrophotography. The exposure time is too short, the resolution too low. Most stars are barely visible, but this streak is visible, and it is moving. The image was posted to NASA's public Mars Raw Image Archive on October 18th. It remained online for 6 hours. Then it was replaced with a note, image, retracted pending calibration review. The image has not been republished. I archived a copy. Now, I am not saying the streak is 3I. I am saying the streak is anomalous. It appeared at the right time in the right location, and it was removed without explanation. And I am saying that 2 independent cameras, one in Mars orbit, one on Mars's surface, captured images of 3I, and both images were deleted. That is not coincidence. That is protocol. Let me give you one more detail. On October 19th, an amateur astronomer in Chile using a 12-inch telescope captured an image of 3I. The image quality was poor. The object was faint, near the detection limit, barely a smudge. But it was there. The astronomer posted the image to a private forum for cometary observers. Within 2 hours, the post was deleted. The user's account was suspended. The forum moderators issued a statement. Content removed for violating data sharing agreements. What data sharing agreements? Cometary observations are public. Amateurs share their images freely. There are no restrictions, unless the object is not a comet, unless observing it without authorization is prohibited. Which brings me to a question. What did HiRise see? What did Curiosity see? What did the amateur astronomer in Chile see? And why were all 3 images deleted? Let me show you something that violates the laws of motion. When an object falls toward the sun, it accelerates. Gravity pulls it inward, and its speed increases. This is basic. Orbital mechanics. The closer you get, the faster you move. But here is the rule. The acceleration is smooth, continuous, predictable. 3I's acceleration was not smooth. Let me show you the data. Between October 13th and October 20th, astronomers measured 3I's velocity using Doppler spectroscopy. By analyzing the shift in spectral lines, they calculated how fast the object was moving toward or away from Earth. On October 13th, 87.3 km/s. On October 15th, 91.2 km/s. On October 17th, 96.1 km/s on air. October 19th, 103.4 km/s. So far predictable. The object is accelerating as it falls toward the sun. Gravity is doing its job, but here is the problem. The acceleration is not constant. Between October 13th and 15th, the velocity increased by 3.9 km/s, an average acceleration of 0.023 mm/s2. Between October 15th and 17th, the velocity increased by 4.9 km/s, an acceleration of 0.028 mm/s2. Between October 17th and 19th, the velocity increased by 7.3 km/s, an acceleration of 0.042 mm/s2. The acceleration is increasing. Now, in orbital mechanics, acceleration does increase as you fall toward the sun. That is expected. But the increase should be gradual, smooth, following an inverse square law. 3I's acceleration jumped. Let me put this in perspective. Imagine you drop a ball. It falls faster and faster as gravity pulls it down. But halfway through the fall, it suddenly speeds up, not gradually but in a single instant. The ball is still falling, but now it is falling faster than gravity alone would allow. That is what 3I did. And the jumps were not random. They occurred at specific moments. October 15th, 0630, UTC, velocity jump of 1.2 km/s over 10 minutes. October 17th, 1445, UTC, velocity jump of 1.8 km/s over 8 minutes. October 19th, 2210, UTC, velocity jump of 2.6 km/s over 6 minutes. Each jump was larger than the last. Each jump occurred over a shorter duration, as if something was firing thrusters, as if something was accelerating deliberately. Now, let me address the obvious objection, but Comet's outgas. The gas acts like a rocket pushing the comet. Maybe 3I is just outgassing asymmetrically. Fair point, but here is the problem. Outgassing produces continuous thrust. It does not pulse, it does not jump, and the thrust direction matters. For 3I to accelerate toward the sun, the outgassing would need to occur on the sunward side, the hottest side where ice cannot survive. Unless the ice is not ice, unless the object is not outgassing, unless it is firing thrusters. Let me give you another detail. The velocity jumps were directional. They did not just increase the speed, they changed the trajectory. After the October 15th jump, the orbital inclination shifted by 0.008 degrees. After the October 17th jump, the eccentricity decreased by 0.02. After the October 19th jump, the perihelion distance adjusted by 14,000 kilometers. Each jump fine-tuned the orbit. Each adjustment optimized the trajectory. By October 20th, 3I was on a perfect gravity assist path, the most efficient route through the inner solar system. And here is the final detail. The energy required for those velocity jumps totals approximately 8x 1015 joules. For comparison, the Hiroshima atomic bomb released 6x 1013 joules. 3I released 130 times more energy in controlled bursts over 6 days. Where did that energy come from? If it is a comet, the energy comes from solar heating, ice sublimating, gas escaping, chemical potential converting to kinetic. But the energy budget does not work. To produce 8x 1015 joules from water ice, you would need to vaporize approximately 3 billion tons of ice. 3I lost 800 million tons. The energy is 4 times higher than the mass loss allows, unless the energy is not chemical, unless it is stored, unless 3I has a power source. I need to tell you about the Allen Telescope Array. The ATA is a radio observatory in Northern California, operated by the SETI Institute. It consists of 42 antennas, each 6 meters in diameter, designed to search for extraterrestrial radio signals. For 20 years it has listened to the sky, scanning frequencies, analyzing patterns, searching for anything that looks artificial. On October 16, 2025, it pointed at 3I. The observation was not publicized. It was not part of the regular SETI survey. It was a target of opportunity observation requested by a single astronomer whose name was not disclosed. The observation lasted 8 hours, from 02 UTC to 10 Yars UTC. The data was transmitted to the SETI Institute in Mountain View, California. It was analyzed using standard signal processing algorithms, looking for narrow-band signals, periodic pulses, Doppler shifts consistent with an artificial transmitter. The results were negative, no signal detected. But here is what is strange. The observation was classified. SETI observations are public. The data is archived, shared, published. Transparency is central to SETI's mission. If they detect something, the world will. No, the October 16th observation was never published. The data was not archived. The observation was not mentioned in any SETI report. It was as if it never happened, except it did. I know this because a data processing technician at the SETI Institute posted a cryptic message on a private forum. We saw something. We were told not to talk about it. The message was deleted. The user was banned, but the message was archived. Now, let me be clear. I do not know what SETI detected. I do not have access to the data. I cannot verify the technician's claim. But I can tell you this. SETI does not classify observations unless they detect something significant. And significant, in SETI's language, means artificial. Let me give you another detail. On October 17th, the Arecibo Observatory in Puerto Rico... Arecibo collapsed in 2020. But its replacement, the Green Bank Telescope in West Virginia, conducted an observation of 3I. Green Bank is the world's largest fully steerable radio telescope. It is so sensitive it can detect a cell phone signal from Mars. The observation lasted 4 hours. The data was processed at the National Radio Astronomy Observatory, and the results were never published. I reached out to a colleague at NRAO. They confirmed the observation occurred, but refused to discuss the results. When I pressed, they said, "We are preparing a paper. It will be released soon." That was 2 weeks ago. No paper has been released. Now here is the question. Why would 2 independent radio observatories detect nothing from 3I and then classify the results? Option 1, they detected nothing and there is nothing to report. But you do not classify negative results. You publish them and move on. Option 2, they detected something ambiguous, a faint signal that could be natural or artificial, and they need more time to analyze it. Possible. But SETI has detected ambiguous signals before. They publish preliminary results and invite collaboration. Option 3. They detected something unambiguous, something so clearly artificial that publishing it immediately would cause panic, and they are waiting for instructions. Let me give you a scenario. Imagine you are a SETI researcher. You point your telescope at 3I, expecting to hear nothing. Comets do not broadcast, but you hear something. Not a voice, not a message, but a signal, a narrow-band transmission at 142 GHz, the hydrogen line, the universal frequency for interstellar communication. The signal is weak, periodic. Every 13 seconds, you check for interference. You rule out satellites, aircraft, ground-based transmitters. The signal is coming from 3I. What do? Do you publish immediately? Do you alert the world? Do you risk causing mass hysteria over a signal that might be artificial? Or do you report it to your superiors, classify it, and wait for confirmation? I think you wait, and I think that is what happened, because 2 days after the Green Bank observation, NASA issued their statement, "Observations of interstellar object C2024S1 are ongoing. Updates will be provided as data becomes available." No updates have been provided. Let me ask you a question. If 3I is broadcasting, what would the signal say? Would it be a greeting, a warning, a set of instructions, or would it be something simpler? A beacon, a signal that says, "We are here, we are listening, we are waiting." Let me tell you about spin. Every object in space rotates. Asteroids tumble, comets spin, planets rotate on their axes. It is one of the fundamental consequences of angular momentum. Objects in motion tend to rotate unless perfectly balanced. And the rotation is predictable. Measure the light curve over time, and you can calculate the rotation period. For most comets, it is between 4 and 20 hours. 3I does not rotate. Let me show you the data. On October 14th, Hubble captured a series of images of 3I over an 8-hour observation window. The brightness varied. We have already discussed the Fibonacci pulses, but the shape did not change. When an object rotates, different faces come into view. A rough, dark side reflects less light. A smooth, bright side reflects more. The brightness oscillates periodically as the object spins. 3I's brightness pulsed in Fibonacci intervals, but there was no periodic oscillation, no rotation signature. Either the object is perfectly spherical, so uniform that every face reflects the same amount of light, or it is not rotating at all. Perfectly. Spherical comets do not exist. Comets are lumpy, irregular, battered by impacts and outgassing, which means 3I is not rotating, or it is rotating so slowly that no change was detected over 8 hours. The Keck Observatory attempted to measure the rotation period using high-cadence photometry. They observed 3I continuously for 12 hours, recording brightness every 30 seconds. Result: no detectable rotation. Upper limit: rotation period greater than 100 hours. For comparison, the slowest rotating comet ever observed has a period of 50 hours. 3I is slower than that, or it is not rotating at all. Now here is why this matters. When an object forms in space, whether by gravitational collapse, collision, or accretion, it inevitably gains angular momentum. Gas clouds collapse and spin faster. Collisions impart rotation. Even random particle interactions cause slow tumbling. A non-rotating object is unnatural, unless the rotation was stopped deliberately. Let me give you an analogy. Imagine you throw a football. It spins as it flies through the air. That is natural. Now imagine the football stops spinning mid-flight, without hitting anything, without friction, without any external force. That would be impossible, unless something inside the football was countering the spin, unless gyroscopes were stabilizing it, unless it was designed not to spin. 3I is not spinning. And there is one more detail. On October 18th, astronomers measured 3I's orientation using polarimetry, analyzing how light reflects off the surface. The reflected light revealed the object's long axis. The long axis was aligned with the direction of motion, perfectly aligned. Imagine a pencil flying through space, point first. That is 3I. Most objects tumble randomly. Their orientation changes as they spin. But 3I is locked, nose forward, like an arrow, like a spacecraft. And here is the final detail. The alignment is stable. Over 5 days of observation, the orientation did not change by more than 0.5 degrees. For a naturally rotating object, that level of stability would require a rotation period of at least 1,000 hours, 40 days, but 3I will reach perihelion in 9 days, which means if it is rotating, it will complete less than 1/4 of a full rotation during its entire passage through the inner solar system. That is not rotation, that is orientation control, as if something is steering it, as if something is keeping it pointed forward, as if something does not want it to tumble. Why? Because if 3I is a probe, if it contains instruments, sensors, cameras, then you would want those instruments pointed at your target. You would not let the spacecraft tumble randomly. You would stabilize it, aim it, control it, and that is exactly what 3I is doing. Let me show you something that should not be possible. On October 19th, the James Webb Space Telescope observed 3I in the mid-infrared spectrum. Webb's MIRI instrument is designed to detect heat, the faint glow emitted by objects at temperatures between 50 and 500 Kelvin. Comets glow in infrared. As they approach the sun, solar radiation heats the surface, and the surface radiates heat. The closer to the sun, the hotter the surface. At 3I's distance on October 19th, approximately 0.3 AU from the sun, the expected surface temperature was 400 Kelvin. Webb measured 290 Kelvin. That is 110 degrees too cold. Now I know what you are thinking. Maybe the surface is highly reflective. Maybe it is covered in ice, and the ice is reflecting sunlight instead of absorbing it. Fair point. But here is the problem. 3I is not reflecting more light. Its albedo, the fraction of sunlight reflected, is approximately 0.04. That is the same as a charcoal briquette. It is absorbing light, not reflecting it, which means it should be hot. but it is not. Let me give you an analogy. Imagine you place a black rock in the desert under the midday sun. The rock absorbs sunlight and heats up. After an hour, it is too hot to touch. Now imagine the rock stays cool, not warm, not even lukewarm, cool. That would mean the rock is losing heat faster than it is absorbing it. But how? In space, there is no air, no convection, no evaporation. The only way to lose heat is through radiation, emitting infrared light. For 3I to remain cool, it would need to radiate heat faster than a normal object, which means its surface would need to be an extremely efficient emitter, or something inside the object is absorbing the heat. Let me show you the data. Webb's MIRI instrument observed 3I at multiple wavelengths. By comparing the brightness at different wavelengths, astronomers can calculate the surface temperature. At 10 microns, 290 K. At 15 microns, 295 K. At 21 microns, 285 K. The temperatures are inconsistent. Different parts of the spectrum suggest different temperatures. That is impossible for a uniform surface, unless the surface is not uniform, unless different regions have different temperatures, or unless something beneath the surface is radiating heat at different wavelengths. Now here is where it gets strange. Dr. David Serida analyzed Webb's data and noticed something unusual. The infrared spectrum contains a faint emission line at 12.3 microns. Emission lines are rare in cometary spectra. They occur when specific molecules, water, carbon dioxide, methane, absorb heat and re-emit it at characteristic wavelengths. But the 12.3 micron line does not match any known molecule. It does not match water ice. It does not match CO2. It does not match silicates, organics, or any common cometary material. Serida proposed a hypothesis. The emission line is consistent with titanium oxide. Titanium oxide is a refractory material. It remains solid at high temperatures. It is used in spacecraft heat shields, rocket nozzles, and high-temperature ceramics. It does not occur naturally in comets, unless the comet is not natural. Let me give you one more detail. Webb observed 3I for a total of 6 hours. During that time, the infrared brightness fluctuated, not smoothly but in discrete steps. At 02:15 UTC, brightness increased by 8%. At 04:42 UTC, brightness decreased by 12%. At 06:30 UTC, brightness increased by 6%. The fluctuations were not random, they were periodic. Every 2 hours and 20 minutes the brightness changed, as if something inside the object was cycling, turning on and off, generating heat, then dissipating it, like a machine. Let me tell you what happened on October 22nd. At 09:30 EDT, the White House press secretary held a routine briefing. The topic was domestic policy, healthcare, infrastructure, the usual. At the end of the briefing, a reporter asked, "Is the administration aware of reports regarding an unusual object approaching the sun?" The press secretary paused, then replied, "I am not aware of any such reports. I will have to refer you to NASA for any questions related to space observations." No elaboration, no follow-up. But here is what is strange. The question was not part of the approved press list. The reporter was from a small independent outlet. The question was unexpected, and the response was rehearsed, as if they were prepared for it. 3 hours later, NASA issued a statement. NASA is aware of interstellar object C2024 S1 Atlas. Observations are ongoing. There is no cause for public concern. No cause for concern. That phrase is important, because it implies there might be a cause for concern, but we, the public, should not worry. Why would NASA say that? Because here is the thing. NASA does not typically issue statements about comets. Comets are routine. Observatories track them, scientists study them, but NASA does not hold press conferences or release reassuring statements, unless the comet is not routine. Let me give you another detail. On October 23rd, the Department of Defense held a classified briefing for members of the Senate Intelligence Committee. The topic was not disclosed, but according to a leaked summary, the briefing included recent observations of near-Earth objects and potential implications for national security. Near-Earth objects. 3I is not a near-Earth object. It is an interstellar object. It passed Earth at 0.5 AU, 75 million kilometers. That is not close, unless they know something we do not. On October 24th, the European Space Agency issued a statement similar to NASA's. ESA is monitoring object C-2024-S1. No unusual activity has been detected. No unusual activity. But we know there has been unusual activity. The Fibonacci pulses, the sunward jet, the nickel emissions, the mass loss, the trajectory corrections. So why is ESA saying there is no unusual activity? Option 1. They genuinely do not know. The data is so compartmentalized that even ESA officials are not fully informed. Option 2. They know, and they are lying. Option 3. They know, and they are waiting. I think they are waiting. Waiting for perihelion. Waiting to see if 3I survives. Waiting to see what it does next. Because if 3I is a probe, if it maneuvers after perihelion, if it changes course or transmits a signal, then the world will need to know. And the government needs time to prepare that message. Let me give you one more detail. On October 25th, the International Astronomical Union convened an emergency session. The topic, Protocols for Reporting Anomalous Celestial Phenomena. The session was closed. No minutes were published. No summary was released. But the timing is suspicious. The IAU does not convene emergency sessions for comets. They convene for planetary threats, asteroids on collision courses, solar storms that could damage satellites, or discoveries that could change everything. Let me ask you a question. If NASA, ESA, and the IAU are all issuing statements, holding classified briefings and convening emergency sessions, what do they know that we do not? Let me tell you what will happen in 4 days. On October 29th, at 1447 UTC, 3I will reach perihelion. It will pass 19.2 million kilometers from the Sun's surface, close enough to be heated to 1,800 Kelvin, close enough to experience tidal forces, close enough that any loosely bound material will be stripped away. If 3I is a comet, it will not survive. The Sun's heat will vaporize the ice. The solar wind will shred the nucleus. By the time it emerges on the far side, it will be a cloud of gas and dust. But if 3I is not a comet, if it is metal, if it is shielded, if it is designed to withstand perihelion, then it will emerge intact, and we will see it. On November 1st, telescopes in the southern hemisphere will have a brief observation window. 3I will be faint, magnitude 12, barely visible to large amateur telescopes, but it will be observable, and we will know. We will know if it survived. We will know if it changed trajectory. We will know if it is still accelerating. But here is the problem. We might not be allowed to know, because NASA controls the largest telescopes. ESA controls the space-based observatories, and both agencies have already demonstrated a willingness to restrict data. So let me ask you, if 3I emerges intact on November 1st, and NASA sees it, and it is clearly artificial, will they tell us, or will they classify the data? Will they release images showing a normal comet tail? Will they issue another statement? No unusual activity detected. Or will they remain silent? Let me give you a scenario. November 1st arrives. Southern Hemisphere. Telescopes observe 3I. The object is intact. No fragmentation, no tail, no coma. Just a solid, dark nucleus moving faster than expected. NASA analyzes the trajectory. The object is no longer on a hyperbolic escape path. It has adjusted course. It is heading toward the outer solar system, but not on a straight line. It is maneuvering. What do? Option 1. They announce the discovery. We have observed an object exhibiting non-natural behavior. Further investigation is required. The world reacts. Panic, excitement, disbelief, governments scramble. The media explodes. Society changes overnight. Option 2. They say nothing. They classify the data. They release edited images showing a normal comet. They issue reassuring statements. They buy time. Time to investigate, time to prepare, time to control the narrative. Which option would you choose? I do not know what will happen on November 1st, but I know this. We are 4 days away from an event that could rewrite history. 4 days until 3I reaches perihelion. 4 days until we know if it survives. 4 days until we see what it really is, and I will be watching. Let me show you something that no one noticed. On October 20th, just before 3I entered the Sun's glare zone, the Keck Observatory captured one final spectrum. The nickel emission lines were still present, still pulsing, still following the Fibonacci sequence. But there was something else, a second set of emission lines, fainter, barely above the noise. Threshold, but measurable. The lines were at wavelengths corresponding to lithium. Lithium is rare in comets. It is a light element, easily lost during planetary formation and almost never detected in cometary spectra. But 3I was emitting lithium at a very specific wavelength, 670.8 nanometers. Let me tell you why this matters. Lithium has two stable isotopes, lithium-6 and lithium-7. In nature, lithium-7 is 92% abundant. Lithium-6 is only 8%. The wavelength of the emission line depends on the isotope. Lithium-7 emits at 670.8 nanometer. Lithium-6 emits at 670.7 nanometer. The difference is tiny, 1/10 of a nanometer, but it is measurable. 3I's emission line was at 670.8 nanometers, pure lithium-7. Now here is the problem. Natural lithium always contains both isotopes. You cannot have pure lithium-7 unless you separate it. And separating isotopes requires technology, centrifuges, electromagnetic separation, chemical processing. Nature does not purify isotopes, but fusion reactors do. Lithium-7 is used in fusion reactions. It absorbs neutrons, produces tritium, and sustains the reaction. Modern fusion reactors use lithium blankets to breed fuel. If 3I contains pure lithium-7, it suggests the object has, or had, a fusion reactor. Let me give you another detail. The lithium emission was not constant. It pulsed, in the same intervals as the nickel emission, 1, 1, 2, 3, 5, 8, 13 seconds. 2 elements, same sequence, same timing, as if both were controlled by the same process, as if both were part of a message. Now I know what you are thinking. This is speculation. The lines could be noise, the isotope ratio could be wrong. Fair. But let me show you one more thing. The intensity ratio of nickel to lithium was 1.618. That number is phi, the golden ratio. The golden ratio appears throughout nature, in spirals, in proportions, in growth patterns. It is one of the most fundamental constants in mathematics, and it appeared in 3I's spectrum, not approximately, exactly, 1.618 to 3 decimal places. Coincidence? Let me ask you, if you wanted to send a signal that could not be mistaken for natural noise, what would you use? You would use mathematical constants, pi, e, phi, the Fibonacci sequence. You would use ratios that do not occur randomly. You would use isotopes that do not occur naturally, and you would pulse them in a sequence that demands attention. That is what 3I did, and then it went dark. Let me tell you what has not been said. Since October 21st, when 3I entered the Sun's glare zone, there have been no updates, no new observations, no trajectory refinements. NASA, silent. ESA, silent. The Minor Planet Center, restricted access. It is as if the object never existed. But here is what we know. 3I will reach perihelion in 3 days. If it survives, it will emerge in 8 days. And then we will see. But I want you to think about something. If 3I is artificial, if it is a probe, a scout, a message, then why now? Why did it arrive in 2025? Why did it enter during this narrow window of human technological development? Advanced enough to detect it, but not advanced enough to intercept it. Is it coincidence, or is it deliberate? Because here is the thing. We have been broadcasting our presence for a century. Radio signals, television, radar. Every transmission leaks into space, spreading outward at the speed of light. By now, those signals have reached hundreds of stars. And if anyone was listening, they would know we are here. They would know we have technology. They would know we are curious. And they might want to check, not with a message, not with a signal, but with a probe. A probe that looks like a comet. A probe that passes through quietly, observing, recording, and then leaving. unless we notice. And we noticed. We detected the Fibonacci pulses. We measured the sunward jet. We analyzed the nickel emissions. We calculated the trajectory. We know something is wrong. And whoever sent 3i knows we know. So now the question is, what happens next? Does the probe complete its mission and leave, or does it respond? Let me give you one final detail. On October 26th, tomorrow, the Sun will experience a minor solar storm. Not large, not dangerous, just a coronal mass ejection, routine and predictable. Except the storm is aimed at 3i. The charged particles will hit the object directly, within hours of perihelion. If 3i is a probe, if it contains electronics, sensors, instruments, the solar storm could damage it. Or activate it. Because here is what happens during a solar storm. Charged particles interact with magnetic fields, induce currents, generate electromagnetic pulses. If 3i has been dormant, powered down, silent, coasting, a solar storm could wake it up. It could trigger a response, and we would see it. On October 29th, as 3i passes through the storm, every observatory capable of monitoring the Sun will be watching. Not officially, not publicly, but watching. And if 3i reacts, if it emits a signal, if it maneuvers, if it does anything that confirms it is not natural, the world will change. 3 days. That is all we have to wait. 3 days until perihelion. 3 days until we know. Let me end with a question. If you were an intelligence capable of interstellar travel, and you wanted to study humanity without revealing yourself, how would you do it? Would you announce your arrival, broadcast a signal, make your presence obvious, or would you watch from a distance? You would send a probe, something small, inconspicuous, disguised as a natural object. You would fly through the solar system, observe the planets, measure the electromagnetic spectrum, analyze the atmosphere, and you would leave, unless someone noticed. 3i was noticed. We detected it. We measured it. We analyzed it. We found 7 anomalies, 7 deviations from natural behavior, and now it is hidden behind the Sun, unreachable, unobservable, beyond our grasp. But in 3 days, it will emerge, and we will. I know, not everything, not immediately, but we will know if it survived. We will know if it changed course. We will know if it is still there, and maybe, just maybe, we will know if we are alone. Because that is the real question, is not it? Not, what is 3i, but who sent it? Not, where did it come from, but why did it come here? Not, is it artificial, but are they watching? I do not have the answers. No one does. But I have the data, the observations, the calculations, the anomalies. And the data says something is wrong. The data says 3i is not natural. The data says we are being visited. Maybe I am wrong. Maybe every anomaly has a natural explanation. Maybe the Fibonacci pulses are coincidence. Maybe the sunward jet is just unusual outgassing. Maybe the nickel is just a chemical quirk. Maybe. But I do not think so. I think 3i is a probe. I think it was sent here deliberately. I think it has been observing us. And I think, in 3 days, when it reaches perihelion and emerges on the far side of the Sun, we will see something that changes everything. Or we will see nothing. And that perhaps would be the most disturbing answer of all. Because if 3i is artificial, if it maneuvers, if it transmits a signal, we will know we are not alone. But if it vanishes, if it passes perihelion and simply disappears, leaving no trace, no evidence, no confirmation, we will be left with questions. Questions that will haunt us for generations. Was it real? Did we see what we thought we saw? Or were we chasing shadows? I hope we get answers. I hope November 1st brings clarity, but I suspect it will bring more questions, because the universe does not reveal its secrets easily. And 3i, whatever it is, has already shown us that. So I ask you one final time, do you think we are being visited right now? Or is this the greatest cosmic coincidence ever recorded? Tell me what you believe, because in 3 days we might finally know the truth, or we might be left wondering forever. The countdown has begun.